In this chapter, we're going to look at probability concepts. So we'll start with basic principles, and then we look at probability distributions, and there are what are called discrete probability distributions and continuous probability distributions. So we will be looking at examples of that kind. Now, probability concepts are very important, and we'll be using probability concepts in several other chapters down the line. So it is very important that you get a solid foundation of probability related concepts. Okay, so these are the learning objectives. Okay, so here are the chapter outline. Okay, so life is uncertain, there is always a probability of stuff happening. All right, okay, so here are the chapters where probability will be used. So it's a list of them. Okay, so there are two basic rules for probability of an event. Okay. The first basic rule is that probability is a number between 0 and 1. Okay, and 0, the value 0 and the value 1 representing certainty. Value 0 means it is certain that the event will not occur, and a value equal to 1 is a certainty that the event will occur. Okay. Now, if a process has several possible outcomes, okay, so each possible outcome will have a probability, and that will be a number between 0 and 1. So that's our first basic rule. The second rule is that if you look at the probabilities of all the possible outcomes and then you add them up, that should be equal to 1. So for example, you have a coin, okay, you toss a coin, and let's assume here that there are only two possibilities, right? You get a head or a tail. So if it is a fair coin, it will be 0.5 and 0.5 adding up to 1. So two possibilities, the probabilities add to 1. Okay, if it is not a fair coin, then it will be a different, the probability of head will be a different number than 0.5, and the corresponding probability of tail will be 1 minus that, because the sum of the two probabilities must always be equal to 1. And another example with more than two possibilities would be like a 6-face die. Okay, if you roll a die and there are 6 faces, then each face has a probability, and when you add all those 6 probabilities, then that sum should be equal to 1. So those are the two basic probability principles. Okay, whatever method you use, whatever way in which probability is assessed, these two basic rules must be true. Okay, if any one of these two rules is violated, then what we have is not a valid probability. Okay, type of probability. Okay, let's first look at subjective approach. Okay, so because we are not going to be using that very much, so subjective approach would be you ask somebody who is very knowledgeable. So you have a baseball game and you have somebody that you trust and has very extensive and deep knowledge about the players and everything, and then that expert comes up with a probability of a particular team winning. Okay, now that would be a subjective judgment based probability, and once again the probabilities principles must hold, the basic principles. Each probability must be a number between 0 and 1, and the sum of probabilities of all the possible outcomes must be equal to 1. Okay, now so that's subjective. So what about objective? The objective approach, there are two basic approaches. One is empirical approach. So that is, you collect data, and based on the data you calculate probability. And then there is classical approach. Classical approach would be using theoretical information. So we'll look at both of them. So let's start with empirical approach. In empirical approach, we repeat what is called an experiment. Experiment is kind of a theoretical terminology. Experiment is anything that can result in, in this context, I'm not talking about scientific experiment. Okay, so here in the probability context, an experiment is anything that can result in one of several possible results. So tossing a coin is an experiment. It will result in either head or a tail. So you have two possibilities, and suppose you repeat that experiment again and again. Then you gather data, and based on that data, then we can compute probability. So number of occurrences of the event, suppose you toss the coin say 50 times, and 30 times you got heads. So 30 times is the number of occurrences of the event. Total number of repetition is 50, so you get 60% or 0.6. Sometimes probabilities, people say probabilities as percentages, but the actual value is between 0 and 1. So that is our relative frequency approach. So let's look at an example in Excel.